All right, today we're putting on our detective hats to solve a cosmic mystery that has stumped astronomers for decades. We're looking at a truly beautiful object in space, and it goes by a few names. NGC 40, Caldwell 2, but you probably know it as the Bowtie Nebula. And just look at it. It's about 6,100 light years away, nestled in the constellation Cepheus, and it's basically the glowing leftovers of a dying star. Now, it looks gorgeous, right? But hiding inside that beautiful cloud of gas is a major contradiction, a real scientific puzzle. And this, right here, is the central mystery we're here to unravel. See, at the heart of the Bowtie Nebula, there's a star that is just fantastically hot. But the gas surrounding it, the nebula itself, well, it's what astronomers call low excitation. It's just not as energized as it should be. It's kind of like finding a massive roaring bonfire that's giving off almost no heat. It just doesn't make sense. So what in the world is going on here? Well, our investigation kicks off right at the heart of the nebula. And that's where we find our first big clue. Something astronomers have called the carbon curtain. This chart really lays out the problem perfectly for us. Over on the left, you've got the central star, HD 826. It's a special kind of star called a Wolf-Rayet. It's low on hydrogen, packed with carbon, and it's blazing away at up to an insane 90,000 Kelvin. Now, look at the right. With a star that hot, the nebula around it should be glowing like crazy. But it's not. It's weirdly dim. The energy level is super low. The math just doesn't add up.
So here's the kicker. The answer wasn't something you could see in ordinary light. To crack this case, scientists had to point their telescopes at it and look at the universe in a completely different way.
And boom, this right here is the breakthrough. On the left, that's NGC 40 invisible light, what you or I would typically see. But on the right, that's the same nebula seen in infrared light by telescopes like Spitzer and Herschel. And all of a sudden, a whole new structure just pops into view. A thick, dusty ring that was totally invisible before. This invisible structure is our first huge clue, the carbon curtain. It's basically a donut-shaped, or toroidal, if you want to be fancy, structure made of thick, carbon-rich dust, and it's wrapped right around that super hot star in the middle. So how does this solve the first part of our mystery? Well, it's actually pretty clever. This carbon curtain acts just like a cosmic lampshade. It's packed with carbon and other molecules that are fantastic at soaking up the star's most intense ultraviolet light. By blocking all that energy, the curtain literally stops the outer dust from lighting up the way we'd expect. And that explains that whole low excitation thing. So, case closed? Not even close. Just when we think we've got an answer, a whole new piece of evidence comes to light. And it shows that this star's death was way more violent and chaotic than we ever thought. Oh yeah, the plot is definitely thickening. What astronomers discovered was that the Bowtie Nebula wasn't made in one single clean puff. No, not at all. It was actually built over thousands of years through multiple, totally separate blasts of material from that central star. When they looked at how all the gas was moving, they pieced together this wild timeline. So about 6,500 years ago, the main barrel shape of the nebula was formed. Then, fast forward a couple thousand years, and powerful lobes of gas got blasted out to the north and south. And then, even more recently, just a couple thousand years ago, even faster jets got fired off inside the main structure. This was definitely not a peaceful ending. I mean, this image really drives home just how chaotic it was. You can see the evidence of all these different events. These blowouts and jets have literally punched through the main shell. And the craziest part? They aren't even all pointing in the same direction. In fact, get this, astronomers have identified at least 4, maybe even more, different directions of ejection. This just completely shatters the simple models of how a star is supposed to die. It's like the star was just firing off cannons in all these different directions over thousands of years. So let's recap. We've got 2 huge clues. A mysterious carbon curtain hiding inside the nebula, and this crazy history of chaotic, multi-directional explosions. The final reveal, the big aha moment, comes when we realize these 2 clues are actually pointing to the exact same, incredibly rare cosmic event. So let's ask the question that finally puts all the pieces together. What single phenomenon could possibly create a brand new carbon-rich dust cloud inside a nebula that was already there and also trigger a whole series of messy, misaligned explosions? The answer is something called a late thermal pulse, and it's an absolutely extraordinary event. Okay, so imagine this. A star is quietly fading out, on its way to becoming a white dwarf. But then, deep inside, a layer of helium suddenly explosively ignites. This actually reignites the star for a short time, making it swell up and violently blast out a fresh shell of material. And this new stuff is poor in hydrogen, but super rich in carbon. And this brand new shell just slams into the old nebula that was already there from a previous eruption. This event literally turns the dying star into a born-again star. And it means our Bowtie Nebula, NGC40, isn't just any old planetary nebula. It is a member of a very rare and exclusive club of objects that have gone through this violent, final burst of life. The carbon curtain? That's the fresh debris from this event. And all those chaotic jets? That's the shrapnel. So, we've solved the case of the Bowtie Nebula. Mystery solved. But what does all of this really mean? What's the big picture here? This quote from the research paper really nails it. Objects like NGC40 are actively challenging everything we thought we knew. They're forcing us to rewrite our models for how stars evolve and die, because clearly the old, simple ideas just aren't enough. So why does all this matter? Well, because NGC40 is proof that the end of a star's life isn't always some simple, graceful fade to black. It can be messy, it can be chaotic, and it can happen in multiple distinct stages. This nebula gives us a perfect laboratory to study these super rare born-again events. But I think most of all, it's just a powerful reminder that even in objects we've been looking at for more than 100 years, there can be profound secrets just waiting to be found, if we only know how to look. And that really leaves us with one final, fascinating thought, doesn't it? This whole detective story, a hidden curtain, chaotic explosions, a star literally coming back from the dead, all of that was locked away inside this one beautiful nebula. It really makes you wonder, if one dying star holds this many secrets, what else is out there just waiting for us to discover it?